Hello, our most valued student. My name is Confident. Welcome to the revision of the Mathematics N1 question paper, which was written in November 2020. This particular lesson is aimed at those who are preparing for their final exams in N1, so as to get some strategies, some concepts, or some ideas that you can incorporate as you prepare for your final exams. Or maybe you are laying your foundation for your Mathematics N2, or for any particular reason you might be interested in getting some ideas on how you could have attempted this particular question paper. And again, this is a Department of Higher Education and Training paper, and as you can see, it was written on the 26th of November 2020 in the morning. It is a 3-hour paper, and in this particular question paper, the requirements were the graph paper, and it says calculators may be used, so you definitely need a calculator. A scientific calculator is what you need. And it says this question paper consists of 6 pages and a formula sheet of 2 pages, and this was the unique code for this particular paper, and it changes in each and every exam sitting. Now let us look at a few instructions. As I said, this is a Department of Higher Education and Training national certificate. It is Mathematics N1, and it is a 3-hour paper. The mark allocation for this particular paper is out of 100. And looking at a few instructions, the first one says, it is actually just to emphasize, some students take this lightly to read the instructions, but it's always good for you to go through the instructions, as it gives you some important information that you need to follow. So I will encourage you to always go through the instructions. They always give you around 5 minutes for you to go through these, so you need to use that time wisely. And the first instruction says you need to answer all the questions. Read all the questions carefully. That is standard. Number the answers correctly according to the numbering system used in this question paper. So don't come up with your own numbering system. You need to follow the numbering system that is in the question paper. And then it says questions may be answered in any order, but subsections of questions must be kept together. Meaning, if you decide to start with any particular question, for example, suppose you decide to start with question number 3, you are allowed to do that. But whenever you start with that particular question number 3, ensure that you answer everything about question number 3. That's what they mean when they say subsections. So you must answer everything about that particular question. Don't answer maybe question 3 of 3.1 and then you go to question 4 of 4.2. So that is mixing the subsections, and that won't be acceptable. And then round off final answers to 3 decimal places. That is very important for you to know. You need to leave your answer up to 3 decimal places. And then it says unless indicated otherwise. Meaning sometimes in the question paper it can say leave it to a specific number of decimals. That's what you need to follow. But if they don't specify, all your answers need to be in 3 decimal places. And then it says question 5.1.4 and question 7.2 must be answered on the graph paper. We will see that as we go through this revision. And then the last one says you need to work neatly. It is also important because work that is untidy can actually lead you being penalized of some marks. Now let us move on and look at the first question, and this is question 1.1, and question 1 of 1.1 says use exponents to simplify each of the following without using a calculator. And we've got 1.1.1. we are given that particular question, and you can see that this particular question was out of 2 marks. If I can make that, so we are saying use exponents. So we are using the laws of exponents here, and we are to simplify that, and also we must not use a calculator, and we are given that a squared b cubed times ab cubed. Again, let me make it bigger. So this is what we're given. Remember, I must not use a calculator, and I must use the laws of exponents. So now whenever you are given this particular multiplication, and again it is the laws of exponents, what you need to focus on is to focus on the bases. There are two bases here. Base A, as you can see, there is our base A, and we have also the second base, which is your base B. Now there are laws of exponents that you are supposed to use. For example, the first law of exponents says whenever there is multiplication, for example, it says a to the power x times, which is multiplication, a to the power of y is equal to, now if you notice, my base is the same, which is a, and when the bases are the same, the law says you have to write that base as a single one, and then the exponents, which is x and y, you need to add those exponents, so it becomes x plus y. So that is the first law of exponents that you need to know. So similarly, when I come to these laws of exponents, you can see that I can actually look at what is common. In between the a squared and b cubed, there is a multiplication sign, so there is a dot, and there is a dot there. So I can actually start with my a squared, and then I can say times or dot. Now I'm given also a, and then I can move on and say times. The other one I'm given is b cubed times b cubed. So what I've just done, I have rearranged and collected like terms. Now whenever you are given the a squared and a, that particular a means there is a power 1 that is hidden. Now I can then apply the law that I showed you here. That is the first law of exponents. When the bases are the same, you add the exponents. So I have got my a, then I must add 2 plus 1, and then times, or you can put a dot. I have got then the b. Again, I do the same thing. The bases are the same. I say 3 plus 3. And then after that, 2 plus 1 will give me a to the power of 3 dot. Again, the other one will give me 3 plus 3 is b to the power of 6. So this is the answer which you were supposed to come with if they said use the laws of exponents. So the answer is a to the power of 3 times b to the power of 6. And you're getting 2 marks for that. Let us move on to the next question. It still says we must use exponents or the laws of exponents to simplify, and we must not use a calculator. And this particular question, it had good marks. As you can see, it had 4 marks. Now, how could you have approached this particular question? If I can expand again. So we are given in this particular question, it says 4 to the exponent x times 8 to the exponent x divided by 2 to the exponent 5x. So there are 2 signs we are given, the multiplication as well as the division. Again, there are 2 laws of exponents. Let me repeat them. The first law of exponents says you are given, if it's a to the power of x, and then dot or times a to the power of, in this case, I mustn't change, it's a to the power of x dot a to the power of y. This is the base is the same, so you add the exponents, which is x plus y. And then you have the second law now, which says a to the power of x. Now instead of times, you have divided by a to the power of y. Now when the bases are the same and there's a division sign, you subtract the exponents, which is a to the power of x minus y. So this is the first law as well as the second law of exponents. So you must remember these most important two laws. So when I look at the question that I'm given 4, I'm given 8, and I'm given 2. Now it is very important for you to understand how 4, 8, and 2 can be expressed in a similar way. Now if I take my calculator, you can see that for me to get 4, I can say 2 times 2, which is 4. For me to get 8, I can say 2 times 2 times 2, which is 8. So I can express everything in terms of 2 here. So which means I can have my 4 as 2 times 2 and my 8 as 2 times 2 times 2. But remember, if I have, for example, 2 times 2 is same as 2 of them, which is 2 to the power of 2. And 2 times 2 times 2, now there are 3 of them, is same as 2 to the power of 3. Now there is another law of exponents, and this particular law, I'll call it law number 3. Now law number 3 says if you are given a to the power of x, and then after that you have got y like that, there is an exponent side, there is a bracket, and then there is a y. This is same as saying a to the power x, then you multiply with the y there. So when it's like that, you have to multiply the exponents. We're going to use these 3 laws in this particular question. Now let us start with the first part. As I said, you can see that 4 in this case is, remember 4 is 4, this is same as 4, and that is same as 8. So 4 is 2 squared, so I will have equal to 2 squared, that is my 4, but there is an exponent x there. I need to put a bracket and put that exponent x there. Again, times, now 8 is 2 to the power of 3 that I need to write. Again, I have to put a bracket, and then I put my x there, and then divide it by 2 to the power of 5x. So if you notice what I've done, I have expressed everything in terms of 2, 2, and 2. Then I can move on using now this particular law, which said when there is a bracket and there are 2 exponents, you need to multiply the exponents. So in this case, you say this is equal to 2 times x is same as 2 to the power 2 times x times 2 to the power 3 times x divided by 2 to the power 5x. This similarly, 2 times x is same as 2 to the power of 2x, and then times 2 to the power of 3x, and then it's divided by 2 to the power of 5x. Now you can go to the final answer using our 2 rules. In this case, we're going to use these 2 rules. Now remember, when there is a multiplication sign, you add the exponents, and when there is a division sign, you subtract the exponents. So that's what I'm going to apply. So it will be 2 to the power. There is a multiplication sign in the first one. So when there's a multiplication sign, I'm going to add the exponents, which is 2x plus 3x. And then the next is a division sign, means I'm going to subtract the exponent, which is minus 5x. You can write it as a single item like that. Then after that, you can actually subtract or use your own calculator, which is, if you're saying 2x plus 3x minus 5 is same as saying 2 plus 3 minus 5, and you can see that it's a 0. So I'm going to get 2 to the exponent 0. Now remember, I'm not using a calculator here, and you can actually test with your calculator 2 to the power of 0. Now if you use a calculator, you can say 2 to the exponent 0. You can see that is giving you 1. You can choose any number. 100 to the exponent 0 is giving you 1. You can choose maybe 41578 to the exponent 0. Just any number is giving you 1. It comes from the laws of exponents, which says a to the power of 0 is equal to a 1. We can call this also another rule or another law of exponents, meaning any number to the power of 0 is a 1. Therefore, you can conclude on this answer to say 2 to the power of 0, it is a 1. Therefore, here our answer is a 1. So whatever you're doing, it all simplified to a 1. So that is how you could ever also approach this question. It was out of 4 marks, but I think it was worth the 4 marks. Now let us move on to question 1.1.3. It says again, still use exponents to simplify each of the following, and we must not use a calculator. And this particular question is 3 marks. We are still looking at that question 1. And this one looks a little bit more not really complicated in a way, but it looks more like busy, that you need to be careful the way you apply your rules. Whenever they're talking about exponents, the main thing that they're testing you are the rules or the laws of exponents. Now let us lay also a few rules here on my right hand side. Now the first rule that we have done is the first law. We said when you're given the exponent x, a to the power of x times a to the power of y, remember when the bases are the same, you add the exponents, which is x plus y. We called it our first law. Then there is a second law, which I'll call number 2, which involves division, which is now I'm going to write it differently for the sake of this question. It will be a to the power of x over a to the power of y, meaning this is same as saying a to the power of x divided by a to the power of y. It is therefore a to the power of x minus y. So you can see that the division sign can be represented by the first one or the second one, but still you're going to subtract. And then the next one we're going to have is the third law, which law number 3, which I said if you're given a to the power of x and then you've got y like that, it means it's a to the power of x times y. We multiply the exponents, and I did include another one, which was 4, which I said a to the power of 0, and in any exponent to the power of 0 is a 1. And also a few rules, as I said in this particular question. When you are given I'll call number 5, when you are given a sign like that, it means in exponent form, this is a square root, it means there is a silent 2. So what it simply means there, it means when you want to introduce the exponents, you put a bracket, whatever is inside there, you say to the power of half. For example, if you say square root of 4, then it means 4 in brackets to the exponent half. That's what basically it means. So we're going to be using all these in this particular question. So now if I can here say equal to, just for space, now I've got a 4 in here. They said I must use the laws of exponents, but sometimes you can see that actually I could have said 4, 2 into 2 is 1, 2 into 4 there, it could have divided like that. but I will choose to use the laws of exponents here. Now you know that 4 is same as 2 to the power of 2. We did it previously. So where there is 4, I'm going to have 2 to the exponent 2, and then there is a times. Now this sign, I told you that there is a silent 2 in this particular square root sign. So you put a bracket and write your 9. Actually, let me already convert the 9. Remember, 9 is 3 times 3. So 3 times 3 is 9, which is 3 to the power of 2, because 3 times 3 is 3 squared. And then I can put still a times, and then I've got x squared, and then I've got times y to the power of 4. Then I put a bracket. What I want you to notice is that particular square here is same as to the power 1 over 2 there. And then continue with times, and there is a bracket there which is x to the power of 3, right, and y. Now because there is a it just says y, it means the silent number there is power 1 there. And then I'm going to introduce this division sign. So it's divided by, what are we dividing? We are dividing by bracket 2x to the power 7 y to the power 4. I think you can see I put a bracket intentionally so that you can see that the division sign is affecting the 2, the x to the power of 7, and the y to the power of 4. And you'll see how I go about doing that. Then this is equal to, I'm going to then use the third law now. It is the third, law number 3 according to here. I'm going to use to open this bracket, because the half, you'll see how it distributes. So I've got 2 to the power of 2 times 3 to the power of 2 times, see the bracket there, that's where the half is going to multiply, times x to the power of 2 again, times, we've got the half that is being distributed. It's more like I'm opening a bracket, and then times y to the power of 4 again, times the half. So I think you can see how the half is being distributed across. Again, when you've done that, I think I forgot a squared here because I must also distribute it. So that it's times, to open the bracket, it will be x to the power of 3, and then it's times 2 times y to the power of 1 times 2, and then it's divided by, I'll still maintain my division sign like that, divided by 2x to the power of 7 and y to the power of 4. This must be protected by the bracket like that. Now the next part that I'm going to do is to look at the common, okay, let's multiply, or remember, multiplying that times that, I get a 1. Again, that times that, I get a 1. That times that, I get a 2. 3 times 2 gives me a 6, and that. So if I simplify it, it will be 2 to the power of 3 times 3 to the power of 1 times x to the power of 1 times y to the power of 1 times x to the power 3 times 2 is 6 times y to the power 1 times 2 is 2, and then it's divided by, in bracket, 2x to the power of 7 y to the power of 4, still maintaining the bracket. Now let us look at what we do from here. You have to focus on the bases. That is the same base, is 2 to the power of 3, and there is, it's 2 to the power of 2 I mustn't write the 3 there. 2 to the power of 2 in there. Now if I look at the bases, I've got also another 2 there. Because it's just a 2, it means there is a silent 1 there. So now because of this division sign between the two, it means I will write it in different pen. It means it's 2 to the power of 2. Now it will be divided by 2 to the power of 1. I think you can see what I'm doing there. And then after that, I have times, I've got 3 to the power of 1. And if I can use also a different pen, now look at our x, and our x there. So the way I'm going to write it, it will be times, I've got x to the power of 1 times x to the power of 6, and then it's divided by x to the power of 7. And then I think lastly I have got the y there, I've got the y there, and I've got the y there. So it will be times y to the power of 1, and then times y to the power of 2 divided by y to the power of 4. So this is how you could have done that. And then again, you have to apply our first 2 laws of exponents. And in our first 2 laws of exponents, this is where what I'm talking about. When there is a multiplication sign, what you do is you add, and when there is a division sign, what you do is you subtract. So that is what we're going to be applying now on this same basis. So you focus on the same basis, and you're going to have equal to, focus on the first one, it's 2. Now the division sign means you say 2 minus 1, and then it's times 3 to the power of 1, and then it's times our x. Now the same base means, the multiplication means you add 1 plus 6, then the division means you subtract the 7, and then again similarly in the y, you have got the y to the power 1 times means plus, you add the exponents. Now the division, which is divided by y to the power 4, means minus 4, like that. So basically that is what you're supposed to do when you're using the laws of exponents. Then this is equal to 2 to the power 2 minus 1. It's 2 to the power of 2 times 3 to the power of 1 times, now 1 plus 6 minus 7 is 7 minus 7, which is a 0, and then times y to the power of 1 plus 2, which is 3 minus 4, is minus 1, like that. So that is what you're actually having there. And you can further simplify to say, in this case, now 2 to the power of 2, it is 4 times 3 times, now x to the power of 0. If you remember law number 4, we said any number to the power of 0 is a 1. So there you will have 1 times y to the power negative 1. So you will have 4 times 3, it is 12 times 1, which is 12 still. So 12y to the power negative 1. This was more like the answer, but I just want to remind you also of another law. In this case, it says if I'm just going to use a calculator just to prove this. If I'm having 1, there is a law which says 1 over a to the power of x. Now it is equal to, now I'm going to write my a. Now to remove this division sign, I will put a negative. Remember, actually let me do it like this as a reminder. Okay, a negative x, but let me redo it like this. If I say 1 over a to the power of x, this is same as saying 1 divided by a to the power of x, if you still remember, which is equal to, now remember 1, any number to the power of 0 is a 1. So I can actually say is a to the power of 0 divided by a to the power of x. I just chose a so that I can match the bases. So now if I'm saying a to the power of 0, remember a to the power of 0 is like a 1. So it will be a to the power of 0, the division means minus x. So this becomes, in a way, a to the power of minus x. If you look at how I did it, I was just trying to work it out for you, that it will end up becoming a to the power of negative x is the same as what I'm getting there. But there is a direct law which says for you to remove the division of 1 over, you just have to introduce a negative there. Now this law works backwards. It says when you are given, for example, same law, a to the power negative x. Now for me to remove this particular negative, I'll say 1 over, and then I'll write a to the power of x. So it's like I'm writing this law in this particular direction. So similarly, in this y to the power negative 1, if I'm saying y to the power negative 1, this is same as to get rid of the negative, it is 1 over, then I'll write y to the power of 1. Hence, when I'm given this particular 12y to the power negative 1, it will be 12 times 1 over y to the power of 1, which is same as this is over 1. 12 times 1, it is 12 over 1 times y is a y. Usually they say leave your answer with positive exponents. That's what they'll be meaning. I think at this stage they would have marked you correct there, but you will see as you work on your N2 and your N3, they prefer the answer to be left with positive exponents, meaning they do not want to see that negative, but they want to see the one there being positive. But this is also enough good practice for you to remember that. So this was a question with 3 marks, but I think it deserved even more from the work that it involved. Let us look at question 1.2. We're done with question 1.1. Now we are looking at question 1.2. Now question 1.2 says simplify each of the following logarithms without, again, we must not use a calculator, and this question was 4 marks. So now we have done the laws of exponents. So the examiners wanted you to show that you are aware of the laws of exponents, or you know them. Now they further moved on to say, let us look at you as a candidate. Do you know the laws of logarithms? So this is what they were bringing in now. Now, in this particular question, if you were to simplify this, again, it is based on some laws of logs that you need to be aware of. Now, I'll start with the first law. Now, the first law of logarithm says, if you're given log in base a of x plus log in base a of y is equal to, so what are you noticing? The bases are the same. I've got base a, I've got base a, and then I've got an addition sign. Again, to mark it with another marker, I'm saying number 1, the bases are the same. Number 2, I've got an addition sign. When it's like this is equal to log, you write that particular base, and then the 2 x and y you multiply as x times y. So when there's an addition, you multiply the numbers. Remember, in the laws of exponents, when there was a multiplication between the bases, you are adding the exponents. But in the logarithms, when there is an addition, you multiply the numbers, provided the bases are the same. That's why you can see that I maintained my log in base of a. That is law number 1. Law number 2 says if these are subtracting, log in base a of x, and then says minus log in base a of y. Now if I'm having same base and a negative sign, it means I will be writing it as log in base A. Now it is x divided or x over y. That's how it's written. Remember, these laws, they go from left to right and from right to left. It depends how you want to write them, but in this case, for this particular question, we're moving from left to right. The next law that I want to make you aware in this particular question, number 3, it says when we are given log in base A of A, now you can see that I've got a number and a base matching. This is equal to a 1. Actually, we can even test this law with a calculator. When I'm given log, for example, in base 10 of 10, it gives me a 1, or log in base 56 of 56 is equal to a 1. So you can see that when the base and the number is repeating, this is equal to a 1. So we're going to use these rules. Now let us look at this particular question then. What we are given here is, let us start with log base 2 of 8. Now, one thing which I always encourage students, remember they say do not use a calculator. Where possible, if you can use a calculator, you can actually find the final answer here and work towards it. So what you do, start with the first one. I'm given log base 2 of 8 equal to, you can take a calculator and ask yourself, what will the calculator give me? Log base 2 of 8, it is equal to 3. So you can see that in a way I'll write this particular 3 like that there. But now how do I get this particular number 3 here? I'll just write it like this to say this was a 3. You write it on a rough work, on your rough work there. Now to get a 3, I must ask myself, how did the calculator work it? Now the hint there is hidden in the 8. Remember, now when I'm given, I did mention previously that there is something interesting with numbers like 2, 4, 8. Now 8 is same as 2 times 2 times 2. So this is same as log in base 2 of 2 to the power of 3. And then with that, I think I need to also come to number 4. The law number 4 says, if I'm given log in base of A of B to the exponent x, now here, if I'm given that, so how do I simplify that? This particular exponent will drop down to become x log in base B of, in base A of B. You can see what happened. I started with the exponent, and then the base did not change, and the exponent and the number did not change. So that is how you work around, meaning I can continue then with this 3 will drop, so that I can have log in base 2 of 2. Therefore I can continue and say this is same as 3. Now using number 3, the law number 3, when the number and the base match, I get a 1. So in here I'll be having 2 and 2 is 3, then it multiplies. There is a multiplying sign there, so it's 3 times 1. That's why the calculator also gave me a 3. I'll do the same thing with my log in base 2 of 16. It will be equal to, also there's something interesting with 16. As I said, as a student you need to know such numbers, but look at this, 16 is same as 2. You can actually try at first, you know that 16 is 4 times 4, but in terms of 2, it is 2 times 2 times 2 times 2. You can see 4 of them will give me 16. So which means you could have written it as log in base 2 of 2 to the power of 4. Again, you follow the same rule. The 4 will drop. It will be 4 times log in base 2 of 2. And remember, when the base and the number are the same, it is 4 times a 1. You could have tested with the calculator here and say, what is log base 2 of 16? You can see that it is also giving me a 4. Lastly, we are given, in this case, 5 log base 3 of 3. In actual fact, this is already more simplified because the 5, remember, is multiplying. So it is 5 bracket. The number and the base are the same. It is a 1 there. You can also test it and say 5 log 3 of 3, and you can see it's giving you a 5. So now you can therefore move on in this particular question. Say therefore this is equal to where there is log base 2 of 8, it was 3 times 1 plus log 2 of 16 was 4 times 1 minus 5 times 1, which is now 3 plus 4 is 7 minus 5. The answer there was a 2. You can also check it with a calculator on this one because it's just numbers. You punch all of it at once and say log base 2 of 8 plus log base 2 of 16 minus 5 log base 3 of 3. And if you simplify, you can see that it is giving you the 2, which is also the answer that we're getting there. So you can see that even with your calculator, you can actually find the final answer, but try to prove that you did not use a calculator. You used the rules or the laws of logs to go about the answer, and then you will get all your marks. And that's the way, when I split it like that, it becomes a better way of seeing how these simplify without using a calculator. Now let us move on to our next question, and it seems this is our last question because it is showing us that the total mark allocation of that question 1 is out of 15. So this is the last one, and this particular question 1.2.2 was 2 marks. It still says simplify each of the following logarithms without using a calculator. If it's all numbers like that, it means I can actually check it with the calculator and see what was the calculator giving me. So this is the question I'm having here. I'm supposed to simplify that, but if I can test the answer with the calculator, it is minus 4 log the base there is 3, and then the fraction there is 1 over 3. Remember, they say I must not use a calculator, but it is good to check what is the answer with that particular calculator. I'm getting a 4 here, so I'm going to say the answer there is a 4. Now let me work towards that particular 4. Now again, everything is based on the laws of logarithms. Now there is a law that I can we're going to apply. In this case, remember, I said these laws, they work in both directions. I showed you law number 2, and law number 2 was saying, if I go backwards, it was saying log base x, log x in base a minus log y in base a is equal to log in x over y in base a. So if I do that and write now in this case and say log in base a x over y is equal to, you can see that now I'm writing law number 2. Now I'm writing it from right to left. So when it's like that, I will then say this is the same as saying log in base a of x. Because of the division sign, I'll say minus log in base a of y. Now again, if I go back, you can see that I'm reading it in this particular direction here. So it's going in this direction. So that is how I'm reading that law. So now with that in mind, that is what I want to apply where there is 1 over 3, such that when I'm given this question, it will be equal to minus 4. Remember, we said the 4 will be multiplying, so you can put a bracket there. It will be log in base 3. You can see the fraction 1 over 3 is like I've got my x there, I've got my y there. So it's log in base 3 of 1 minus log in base 3 of 3. That's the first part that you need to be aware of. Now, when I've done that, is equal to, I will also I'll consider it as law number 5 or rule number 5 here, because I didn't have it. Now, rule number 5 says if you are given log in base a of 1, it is equal to 0. Now, meaning any number, any log 1 is a 0. Let me show you with a calculator. For example, I can say log in base 2 of 1, I'm getting a 0. Can say log in base 58, and then I say 1. The moment I say log 1, whatever base, it will still give me a 0. So which means here also, you can see that I have got log base 3 of 1. So if I say log base 3 of 1, I can actually write it as 0. So it will be minus 4 there. It will be negative 4. And then I've got 0 minus. Now you can see that log base 3 and 3. If the base and the number are repeating, if you remember here on number 3 here, we said this is equal to a 1. So which means here I'll be saying minus a 1. Now it is equal to minus 4. 0 minus 1, it is minus 1. So I've got minus 4 times minus 1. The negative 4 times the negative 1 is a positive 4. Your calculator can actually multiply that and say negative 4 bracket minus 1. It gives you a positive 4, which is the same answer which I got before I used the calculator. So that is how you can solve that. Now, I hope this gave you some hints or some strategies, and you are going to incorporate them as you work towards your exams. And these ideas, you can actually go over them again and again. It's good because it's a video which you can repeat again and again. Now, everything that I was teaching here is intensively covered in the Mathematics N1 textbook for the underdogs, whereby I cover each lesson again in the textbook, which is followed by a video of the same lesson. So it will be good or wise of you to grab hold of that particular textbook as well as the videos, so that you can be able to use the laws the way I'm using them. And trust me, you'll be able to easily pass this exam. So these concepts that I'm using here are already covered in that particular textbook. So I will encourage you to grab hold of that textbook and use it as you prepare for your final exam. We have come to the end of our lesson. Thank you.